Hello everyone and welcome to my video, and if you have not yet subscribed, please subscribe and turn on the notification bell on so that you do not miss any of my videos. So today I'll be talking about linear regression. So in this first part of the series I'm going to be talking about the linear regression with one variable. So let's say you are a machine learning engineer and then you are hired by a real estate to create a model that predicts the price of house prices based on the size of the houses in feet. So how would you do that? So in this case we have two variables. We have the size of the house, which is measured in feet squared, and then we have the price in dollars, which is in thousands. For example, if the size of the house is 2,500 feet squared, then the price is 500,000. So we have this problem. So how do we create a model that helps the real estate company to predict the prices of houses based on the size of the houses? So the first thing we are going to take a look at the notation. So in this case the notation is we are first going to take a look at the notation. So M in this series is going to represent the number of training examples. So this is the number of training. This is the number of training examples. And then X is going to represent the input features. Y is going to represent the target variable. Over the output feature. So X is also called the independent variable. And then Y is also called the dependent variable. Since our output is dependent on the value of X, that's why it is called the dependent variable. So let's look at our data set. Let's say in this case, if we have 52 rows, so in this case the number of rows is 52. We have 52 rows. So the number of training examples in this case will be 52. So the number of rows in this case is 52. So let's take a look at this example. So in this case I have made a graph. In this case I have made a graph in which we have the price in dollars, which is on our y-axis. So this is the price, and then we have the size in feet squared, which is on our x-axis, or which is our x variable, our input feature. So the value of the price depends on the variable x, or the input features. That's why this is called the dependent variable. This is called the independent variable. So in this case, how do we create a model that helps the real estate to predict the price of houses? So let's say in this case we draw a line. We draw a line that separates our data set. In this case, we draw a line that separates our data set. So in this case, let's say if someone wants to buy a house from the real estate. Let's say someone wants to buy a house of size 2,500 feet. Let's say this is going to be 2,500 feet. Then in this case our model is going to predict that the price of the house will be somewhere around 290,000. It will be around $290,000. So this is how linear regression works. So this is called linear regression. So this is a regression type of a problem where our output is a continuous variable. As you can see, the output is a continuous variable. The price is a continuous variable. So now, how do we represent our model? So to represent our model, we need to be hypothesis. So let me show you how the hypothesis works. So this type of problem was a supervised learning where we provide our model with both the answer. We provide our model with the values of x and the values of y. We provide our model with answers. We provide our model with examples at the same time with answers. So in this case, we have a training set. So we have a training set, and then we feed the training set into a learning algorithm, which the learning algorithm, which was our linear regression model, which we created for our real estate company, and then the learning algorithm creates a hypothesis. So the hypothesis then predicts the estimated price. The hypothesis then predicts the estimated price from the size of the house, which was in feet squared. So H here, H represents the hypothesis. So what is a hypothesis? So in this case, a hypothesis takes an input. So H, the hypothesis, takes an input X and tries to estimate the value of Y. So in this case, X was the size of the house in feet squared, and then Y was the price. So in other terms, the hypothesis is just a function. So the hypothesis is just a function which takes in X and then predicts the value of Y. Or in other say, we can say that H maps from value of X's to Y's in this case. So now, how do we represent the hypothesis? So to represent we represent the hypothesis as h theta of X is equal to theta 0 plus theta 1 times X, where theta is the parameter. So theta is the parameters. Theta is the parameter. So we have theta 0 and theta 1. So I'm sorry for that. So in this case, theta is the parameter, and then as you can see, the hypothesis h theta is a function which takes in an input x and tries to predict the value of y. So let's try to visualize our hypothesis graphically. So I'll just, so in this case, say the hypothesis, our hypothesis h theta x, which takes in a value of x, is equals to theta 0, which is a parameter, plus theta 1 times x. In this case, our hypothesis has 1x because this is a regression problem with only one variable, or a univariate regression model. So we are only considering, in this case, we're only considering the size of the house in feet squared. But as we progress, and as I'll progress down the series, I'll also show you how to create a linear regression model hypothesis with more than one variable. Let's say, for example, now we can determine the price of the house based on the location and also the size of the house in feet squared. So if we draw a graph, x and y, so this is y and then this is x, and let's say we have a point here. So what our hypothesis does is it tries to create a line that best fits our data set, So this line is the hypothesis. So this line is h theta of x, theta 0 plus theta 1 x. So this line is the hypothesis, which is also the linear regression model. So thanks for watching, guys. I hope you understood what linear regression is. So in the next video, I'm going to talk about the cost function for linear regression, or how we can best fit our line to our dataset so that we can make our predictions accurate. So thanks for watching, guys. So if you have not yet subscribed, please subscribe and turn on the notification bell so that you do not miss any of my videos. Cheers.